Hi, this is a builder's log on the HOVERTHINGS FPV Pro, PIXHAWK from 3D Robotics for the flight controllers, and Frsky Taranis for the RC transmitter and receiver end of it. And here she is fully assembled. I've flown her for a couple of months now, and there's some modifications I'd like to do, so thought I'd tear her down and do a complete rebuild from the dirty plate, the lower dirty plate. We'll cover the upper dirty plate, lower clean plate, and upper clean plate, and why I chose the components I chose. And if I was to do anything different, well, we're going to be doing those things now. Okay, I've got her stripped down to the dirty plate. As you can see, power wiring board, well, actually power wiring harness. Electronic speed controllers, I like to wrap those up in aluminum foil, and then the copper foil tape that you can get online from several sources, but I get them from online from Home Depot. It's like $7 for a roll, sticky back. So once I wrap them with a little bit of aluminum foil, then I put a washer with the grounding wire off of it and put the copper foil tape over it. Anything that can put out EMI, RFI, I'm going to wrap them in foil and give them a grounding wire and tie all the grounds together. You have several different choices here with the power distribution. You can go with making your own board and soldering it all up. I elected not to go with doing that way. From 3D Robotics, they have a power distribution board that you can use, but this won't fit inside here. The profile is a little too tall, or these standoffs are a little too short. If these were another 3 millimeters space between the bottom dirty plate and the next dirty plate up, there would have been enough room for this. There's this style also, but I just didn't see this one as being as conducive or as easy to set up inside here, so I went with this harness here that I got from Ready Made RC, and this worked out pretty well, since the bullet connectors that come off the electronic speed controllers, these are Tiger motors, 25 amp with no BECs in them, hence the red wire has been removed from the servo connector and heat shrunk in a harness here, and on this end there's no wires that come off of the electronic speed controller. You've got leads coming off the motor with bullet connectors that go directly into electronic speed controllers. So the wires, the lead wires that come off the Tiger motors aren't long enough to accommodate having the electronic speed controllers inside, which I see a lot of people like to do on top of the dirty plate. They weren't long enough, so I would have to splice in more wires, which would have meant more connectors and more areas to fail. So I just elected to go with a system that allowed for the least amount of work and the least amount of connectors. So that is what we have so far here. With BEC, I came off of the harness here with a splitter, so I had two to tap off of, which gave me one for future needs and one going into a battery elimination circuit BC regulator that puts out both 5 volt and 12 volts. So for video systems or camera systems, some of them require 5 volts and some of them require 12 volts. So I've got both right here, and I am using both receiver here and for the camera system here. I also have all, as I mentioned earlier, all these black wires here are to the grounds around all components, and more which you'll see soon, all tied together and back to neutral or ground. I will add why I chose this frame. Well, I like the idea, the concept of the elongated frame to allow more surface area to put some distance between the components, and it makes it a little less cluttered for the wiring. For example, when you've got something like this where everything has to be right in the middle, you end up with one spaghetti nest of wiring, and it doesn't put a lot of distance between components. They're all stacked on top of each other. So this gives it more spacing, and this design also has 4 plates, so it gives you more space, against more surface area for putting some distance between the components. Next is the next plate here is the I call the upper dirty plate, since there's 4 of them. One of the first things I did, I noticed that these edges all in here are really sharp, and over time I would imagine where you've got these wires coming up through here, there's going to be some chafing and cutting into the wires, so I just basically took an X-Acto knife, actually I took a dull one, and just took away the sharp edges wherever I was going to pass wires through. I see there's some here I still didn't hit, but that's probably because I don't have wires coming up through there. This is the power module from 3D Robotics. This goes to the PIXHAWK, and I would have preferred to mount this more inside, but the profile of it wouldn't allow me. There just wasn't enough space between the 2 plates, so it hangs off to one side. But as it turns out, I can easily disconnect it and disconnect the battery from this side and disconnect the power wiring harness from this side, and I sort of like it. It's not as pleasing to the eye, but I think it's more functional that way. So we pass these through here. My 5 and 12 volts start going up through, and then bring the wiring from the ESCs to top side on top of this plate here, and then I will stop the video and make it nice and neat. Now I've got the 3rd plate on, which I refer to as the lower clean plate, secured on the 4 isolation dampers. These 4 locations here. The nuts are 5.5 millimeter, which makes it sort of an odd size for wrench wise. Then we have leads coming up from our BEC for our 12 volt and 5 volt. They lead into the noise filters. Here we've got a lead coming off the camera that'll go into the MINIM OSD board, and a frame ground that comes off of the camera. Frame ground also on the back here off the telemetry radio. And we have our PPM wire going from the receiver. Well, this will be going to the receiver once we get the next plate on, and also this will be going for RSSI off the receiver, the radio control receiver. Here we've got 4 servo leads coming in through the main output, and one side positive, these are all secured in place. I like to put a little bit of liquid tape on them to hold them in place, but then again you can easily cut through it or just pull the connectors out, just keep them from backing up from vibration. And is that pretty much it? Well, the rest is sort of self-explanatory, but you know, you got your buzzer connector, you got telemetry 1 to the 3DR telemetry radio, power coming in from the power module, and here those are all self-explanatory and labeled. Before I install the top plate, I thought I'd quickly review while we can here. Turn it over. You can see where the foam mounted video transmitter is located. These are all just mostly just grounding connectors and wires to a frame ground here with the copper tape, foil tape. I'm replacing 3DR's radio, which is also 5.8 gigahertz, with an immersion RC so that I can match the bands on my Fat Shark goggles. They don't match on this here. I can get them on a monitor, but I can't get them on my goggles, so with this one I'll be able to do that. And here's pretty much the final product with all 4 plates mounted. We've got the mast that folds down. I wish it folded other directions so that if you do crash upside down, it's less likely to break. This is nice for folding it down and carrying it, flipping it over and putting the battery in. Also just a rubber band for spring load for the diversity antennas. Let's see now, in terms of props. Well, since they're Tiger Motor props, I went the Tiger Motor adapters, but I went for the cheap carbon fiber blades to start with. once break-in time is done, well, no pun intended, then we can go to the expensive Tiger motor props too. I personally prefer the 3-hole system versus a single hole. I always wonder how tight and whether it's going to spin or if the nut's going to come off. I did go with left hand and right hand threaded mounts so that when the motor turns one way, it actually wants to tighten up the nut for when they turn counterclockwise. You know, the nut wants to tighten if it's a left-handed thread. The adapters, I don't know if you can see on here, but the short adapters have this knurling on them for grabbing the prop. But unfortunately, the short adapters don't accommodate the blade, the spacer, and then the nut. They're too short. So having to go with the long shaft on the adapters. Unfortunately, these, I don't know if you'll be able to tell, but on these, they're not, the long ones are not knurled, so I'm always concerned about slippage, but it hasn't seemed to be a problem yet. The roll cage I did just in case in the beginning if things didn't go as planned. I would protect some of the components on top, protect the camera and the MINIM OSD and the receiver. Luckily it hasn't really needed to be used. I used basically antenna tubing. Inside the antenna tubing on these two ends I used music wire, 55 thousandths music wire, and there's just collars that go through that tie in underneath here where the wires come through. But I didn't want any metal inside these tubes that close to the compass because it will affect the compass. You can take a pair of glasses, a wire rim glasses for example, and bring them further and closer away from the compass, and on the laptop or on the tablet you can see the swinging of the compass inaccuracies. So I went with carbon fiber rods inside. These are not antenna tubing, these are styrene tubes because the inside diameter of these couldn't accommodate the carbon fiber rod. So these have carbon fiber rod to here and then metal further down where I needed to make the bends. The carbon fiber rod doesn't bend that well. You get some flexing out of it, but they don't bend. But it has turned out to be a pretty stout and pretty strong framework for on top of it. What else is on my list? Well, the props are 9" by 4.5s, so for every full 360 degrees forward, for every 360 degrees you get 4.5 inches forward movement. And one-way folding mast, the wiring diagram. Well, here's sort of a quick view of how things are connected, hardwired from one component to the next. And the other item is, if you have the opportunity, if you can, the ribbon cables is hard to do, but if it's a non-ribbon cable, twist them up. That'll help reduce noise, electrical interference noise. The rubber ducky antenna, the whip antenna for the 900 megahertz for the telemetry. I've pushed the limits on its range, and so you lose the telemetry on the tablet when you're flying with the tablet. So I'm going to try with a right-hand circular polarized antenna on the transceiver. I'll have this out here, try it out and see how this works out. I know I'm adding more connectors, but I still like to see if I have this set up, I can get better range with telemetry, and obviously also have the right-hand circular polarized clover leaf antenna on the transceiver on the tablet end. And there she is, ready for calibration. And we'll give a quick view of all the sides. I've got the 5100 milliamp 4S battery on there right now. I haven't run it with that size battery. I have run it for as big as the 4S 4300 milliamp batteries, and I've also run it on some 3S batteries. Flies very well, either with the sticks or autonomously. There she is. Get the props on after we do calibration. Alright, thanks for watching, and happy flying.